Up to this point, we've done two things. You have to recognize the difference. If you see a rational expression that is multiplying and dividing, what are you doing to solve for that? If it's multiplying or dividing, you're factoring and then you're canceling out. Okay, you do not use the LCD. Okay, when you see two fractions or rational expressions that are being added or subtracted, then you have to find the LCD and you add only the numerators together. Very good. Because when you're multiplying and dividing, once you break everything down, after you cancel out, then you multiply straight across, numerator to numerator, denominator to denominator. So you have to be able to tell tomorrow on the quiz the difference. First of all, first thing you ask yourself, are they multiplying or are they dividing? How many problems have we multiplied and divided together? Or I should say, how many problems do we add and multiply together? We haven't. We haven't done that yet. Either you're multiplying your fractions together or you're going to be adding and subtracting them together. We've never combined those, which we never will combine them. Okay? Not right now anyway. Okay? So, now we're getting into something completely different. Now we're doing solving rational equations. So you hear equations, and that tells you what's now is in our problem. An equal sign. And honestly, of the three lessons, this is by far the easiest one. By far. Okay? I say that with a straight face. By far the easiest one. Okay? Alright, so what we're doing. Well, no, he's not being sarcastic, he's being serious. By far the easiest lesson. Alright, so let's look at this. Here we go.
It's like 1 plus
5 over x plus 1/3 equals 6 over x. Alright, now you've been taught in math that the hardest math problems you encounter are always the ones with fractions. So anytime that you can get rid of the fractions, we get rid of the fractions. Okay? So what we're going to do is we're going to combine our LCD to each part of the fraction so we can cancel out our denominator so we don't have to worry about the fraction. So the first thing we want to do is we want to look and find out what my LCD is. If I look up here, we're still accounting for every term in the denominator. My LCD is what? 3x. So what you're going to do with your LCD is you're going to times it by each fraction. So I'm going to multiply it by 3x. I'm going to multiply this by 3x. I'm going to multiply this term by 3x. By multiplying each term by 3x, I can look at this and say, okay, what can I cancel out? This x will cancel out this x, and what am I left with? 15. My plus sign. What cancels out here? 3. The 3 will cancel out the 3, and what am I left with? X, or 1x, but what you put, equal sign. What cancels out here?
X.
The x will cancel out the x, and what am I left with? 18. By doing that, you completely got rid of the denominator, which means you don't have to worry about those fractions anymore. Now you're back to basic 7th grade, 6th grade Algebra 1 statement. How do I solve for my x? Subtract 15, x equals 3, and you're done. The only thing you have to worry about, okay, we're talking about extraneous solutions back in the day, okay? You have to look, and if you would ever put this problem in for x and it gave you a 0 on the bottom of a fraction, it's an extraneous solution. You don't care about the numerator. You only care about that if you put this in for something on the bottom, and if it comes out to be 0, extraneous solution. That's the only time. Okay? Here you have to worry about it because you put 3 in for x and 3 in for x, you're good to go. Alright? You can never have 0 at the bottom of your fraction because in your calculator you come up with what? Error. Okay? My college instructor always told me your problem blows up. You can never have a 0 at the bottom of your fraction. It doesn't exist. Alright? So therefore, that's the only thing you gotta check when you go back. Your goal is to multiply each term by the least common denominator to cancel out your denominator. And then you go and solve. You get down to algebra basic, it's easy.
So we don't have that
No.
Are you funny?
Alright. Okay, next one, here we go. Okay, we got 8 over x squared minus 9. 8 divided by x squared minus 9. We've got plus 4 over x plus 3 equals 2 over x minus 3. Alright? Now, just like before, if you have something on your denominator that needs to get factored down, that's the first thing you got to do. This is a difference of two squares, so therefore, what will this break down to? X plus 3, x minus 3. Okay, so I'm going to get rid of this. It's not there no more. Okay, so now my LCD is what? X plus 3, x minus 3. I counted for every term. Okay, so now I've got to multiply each term by x plus 3 and x minus 3. So I'm going to run it up here. X plus 3, x minus 3. X plus 3, x minus 3. X plus 3, x minus 3. And yes, I'm going to have those people that are saying to themselves right now, that's too much work. I'm not writing it down. I'm going to do it in my head. You're going to screw up. You're going to get it wrong. You're going to come back and say, I just don't get why I'm missing it though. Because you're not doing what I asked you to do. Okay, if you'll remember to write this stuff down, guys, you can't miss it because it's telling you what to do. But you've got to write it down. It took us 5 seconds to write that extra down. It's not that much extra work. Yes?
Could you have done though, like 8x squared minus 9x squared minus 9x squared minus 9?
You could, but it's awfully hard to cancel out an x squared minus 9 when you only have x plus 3 here.
Oh, okay.
See what I'm saying? But it's the same thing. It's less writing, but then when you cancel, what you need to see cancels out, you got to rewrite it anyway. Okay, so now you ask yourself, my x plus 3 will cancel out my x plus 3. My x minus 3 will cancel out my x minus 3. What am I left with? 8 plus. My x plus 3 cancels out my x plus 3, so what am I left with? 4x minus 12 equals, my x minus 3 will cancel out x minus 3, so what am I left with? 2x plus 6. Alright, now I have, where I have variables on both sides of my equal sign. My rule is what? I take my smallest to the largest because it always keeps my variable positive. So I'm going to subtract my 2x. As I subtract my 2x, I'm going to combine my like terms on this side also. So 8 minus 12 is negative 4 plus 2x equals 6. Add 4 to both sides. 2x equals 10. And from there I can see that x is going to equal 5. I check. If I put 5 in here, I get numbers, I get a number, I get a number, no zero, so you're good. So x equals 5. By far easier than the last 2 days.
Yeah.
Okay, your goal is you still have to use your LCD to cancel out your denominators and you're good to go.
That's way easy.
Alright? Alright, so, no, Brett, we're still not done.
I was about to ask you
I
this
know.
now.
Yeah, Will's gonna take Alright, what happens if you have this? 3 over x plus 1, 3 over x plus 1 equals 5 over x minus 1. Okay, here we don't have a fraction plus a fraction equals something. Here we just have a fraction equals a fraction.
Cross multiply.
The easiest way when you have a fraction equals a fraction is what?
Cross multiply.
Cross multiply. That's what you learned back in 6th grade and it still works right now. If you ever have a fraction that equals a fraction, don't worry about your LCD, just cross multiply. 3 times this gives you what?
3x minus 3.
Cross multiply. 5 times that gives you what?
5x plus 5.
And then solve. So even when we're having a fraction equals a fraction, don't worry about your LCDs, just cross multiply and solve. Make life easy. You still have to use rules and stuff you learned back in the good old days, and it'll make your life easier because it's so much faster. If you want to find your LCD, you still could, but what you're actually doing is you're still cross multiplying. Because your LCD would be what? X plus 1, x minus 1. You're asking yourself here, what part are you missing? I'm missing my x minus 1, so I have to write that up there. That's the same thing as cross multiplying. What part are you missing here? My x plus 1. Well, I'm multiplying by x plus 1. It's the same thing as cross multiplying. It's just more work. Alright, we'll do one big one and then we're done. And you're gonna have have almost 40 minutes to work on your homework tonight, which is a good thing. You should, the other class got every problem done and didn't have any homework, so that's good. You only have 15 problems, and I've already done a bunch of them. Alright, here we go. 13 or 14. 13 or 14. 13 or 14. Which one do you want to do first?
14.
You see 'em? 13. Good job, right. 13.
That's an unlucky number.
I think
13
you're
every
saying-
time. What happens if you try to
I'm so confused.
2x minus 1
Oh, this problem.
divided by
13.
x squared plus 2x minus 8. X squared plus 2x minus 8 plus 2 divided by x plus 4 equals 1 over x minus 2. Alright, so the first thing we have to do is what?
Greatest common.
We gotta factor that. So if I factor that, I break that down into two binomials. I got x and x, plus and minus. Factors of 8, when I subtract, will give me 2. 4 and 2. And so thank goodness they're the exact same thing as which I already have, which makes life easier. So I'm gonna get rid of this right here. I'm gonna put x plus 4 and x minus 2. Alright. So now my LCD is what? X plus 4 and x minus 2. I'm accounted for every term in my denominator. So I'm going to multiply each fraction by my LCD. So I'm going to multiply each term by x plus 4 and x minus 2. X plus 4, x minus 2. X plus 4, x minus 2. Multiply each term by each fraction. Why are we multiplying each term, each LCD by our, I said that wrong. Why are we multiplying each term by the LCD? What's the concept? Why? To cancel out our denominator. So we have an easy problem to work with to solve for x. Alright, so I look at this. My x plus 4 is canceling out my x plus 4. My x minus 2 cancels out my x minus 2. What am I left with?
2x minus
2x minus 1. Plus, my x plus 4 cancels out x plus 4. What am I left with?
2x minus 4.
2x minus 4 equals my x minus 2 cancels out x minus 2, so I'm left with
X plus 3.
x plus 4. Okay, what should we do first here?
Combine like terms.
Combine like terms. 2x plus 2x is 4x minus 5 equals x plus 4. Now I'm going to do what? Subtract x. I'm going to subtract x, but while I'm subtracting x, I'm going to add 5 at the same time. So that gives me 3x, cancels out, equals 9. So I see that x equals 3. I came back up here. If I put 3 in there, I get a number, I get a number, I get a number, and I get a number. No zeros. So my final answer is x equals 3. Okay? Easy enough, right?
Yeah.